If you have microarray data for the same samples as your RNA-seq data, you can compare them in Array Studio. Our CCLE tutorial dataset have data for RNA-seq and microarray, so we will compare them. First, we will add our microarray cell files. Locate the files on the server. And click Send to Queue. This should be a relatively quick analysis. When importing is completed, go to the Analysis tab and click Update Project. Now, let's attach a design table to our new microarray data. To see our design table, we need to add a table view. Under Annotation, we can look at the annotation table and see that the probe sets are already associated with gene symbols. These gene symbols will be used to integrate with our RNA-seq data. By default, microarray data are imported using RMA, so they are already log2 transformed. We should compare our microarray data to our log2 transformed RNA-seq data. Our RNA-seq FPKM expression data are under omic data, so they can be used in any microarray analysis, including integration, such as Microarray-Microarray Integration. For the first dataset, let's choose our log2 transformed RNA-seq data and choose our microarray data for our second set. Choose the column titles to match the gene names between the sets. And the titles to match our samples. Let's name our samples. And output. And submit. For every gene that could be matched between the microarray and RNA-seq datasets, you will see a point for every sample. RNA-seq data are on the x-axis and microarray data are on the y-axis. Although we have over 30,000 genes in our RNA-seq data and over 50,000 probe sets in our microarray data, only 17,000 were matched between the datasets. This can be improved by better mapping of our gene symbols. We can add a regression line, and directly view the underlying data. In our annotation table, we can see and sort by correlation and p-values. We can add a histogram view to our annotation to see how strong the correlations are. In addition to viewing the correlations by each variable, we can also view the correlation by each sample. For each matched sample, each dot represents one gene. Again, the matching is only as good as the correlation in the gene names. You could use more consistent IDs, such as ensemble IDs, to improve this matching.